Hello, today we're going to be doing 5.1 notes. Welcome to a brand new semester. Inequalities and triangles. So we're learning more about triangles for this first unit. So our objectives, you will be able to use relationships between sides and angles of a triangle. You will be able to find range of values for an unknown side of a triangle, and you will be able to determine if a triangle can be created when given three side lengths. So first, let's go ahead and start with this first exploration. So I'm going to go ahead and open that on this other screen, and make sure you have your notes out or on a separate what is it called, a web browser, so that you can try and do both these at the same time. I'm just going to kind of move these to wherever I really need to move them. You can move them to whatever lengths you want, because we're going to have to do this a couple times. So after you come to this page, this exploration page, you're going to move the vertices around, pick a spot, and then you're going to answer the question. So it's asking which angle is the largest, which angle is the smallest, which side is the largest, and which side is the smallest. So go ahead and take a second, look at that, and write down what you got. Alright, let's go back over here. So I ended up with angle A being the largest, angle B being the smallest, because angle A was 83 and then angle C was 43, with B being 54 degrees right in the center. And I know I said C and wrote B, my bad. Alright, and then we want to know which side is the largest, which we have BC, and then which side is the smallest, which is AC. Alright, so now we want to go ahead and do this one more time and repeat the same questions above. So let's go ahead and just, I don't know, kind of move them around a little bit. I feel like that's a little too small. Let's do that. Okay, so now go ahead, take a second, write down what is the largest, smallest of the angles and the sides. Alright, let's go ahead and go back for a moment. Oh, wrong one. There we go. And I also realized here, I accidentally wrote the wrong one. I was trying to write it quickly, so I can write it down for you guys, but then I realized I totally wrote the wrong one. This one should be AB, so the smallest side of that first triangle I did. Alright, let's take a look at the second triangle. So with the second triangle, I have the angle C was the largest, angle A was the smallest, and then side AB was larger, and then BC was smaller. So what do we notice about these? So between the different triangles, and you can keep going back and forth, and you can move it around as many times as you need to really try and figure out what is going on with these triangles. So I'm going to give you a second and come up with what do you notice and a conjecture, then we'll talk about it. Alright, so what I noticed about these is when we have this triangle, the opposite angles and sides, so let's make this super easy to do. Let's do 3, 4, and 5. The opposite angles and the opposite sides are going to be the largest. So therefore, angle A, even though I have no clue what angle A is, I know that angle A is going to be the largest side. Because taking a look at our example here, 8 is the largest, so A is the largest over here compared to 43 and 34. So that's going to be true no matter what you have. So I can continue to move that up more. We have 8 and 8, so I have 68 and 69. It must be super close decimal-wise wherever I moved it. But you can see here that they're all going to be very close to one another. And depending on which one is larger, the opposite side or the opposite angle will coincide with that. Alright, so let's go ahead and talk about the inequalities in a triangle. If any triangle, or in any triangle, the largest angle is across the largest side. And then also the smallest angle is across from the smallest side. So if we take a look at this, the largest angle is across from the largest side. So my largest side is 75, and therefore 115 is my largest angle. And then I can also do that with the smallest. So my smallest side is 28.28, and then across from that we have 20 degrees, which is our smallest angle. So that all is true. So let's go ahead and try this first example together. So we want to identify the longest side and the shortest side. So longest, so we're going to take a look at this angle, so 70 degrees. I'm going to go across, so my longest side is BC. And then we can do the shortest. All we have to do is take a look at the smallest angle and then go across. So AC is my shortest. I also noticed that angle B is my shortest angle, and I just use the other two letters for the side. And same thing with my longest one. Alright, I want you guys to go ahead and try example 2. I already have it filled out, so I'll scroll over to it in 1 second. Alright, here is angle 2. We have the smallest, or the shortest and the longest, with the smallest angle and the largest angle. Alright, let's go ahead and go to the next page. So let's take a look. Now we're just going the opposite direction. And one thing I forgot to talk about with 1 and 2 is there's a key part here where it says reminder diagrams are not always drawn to scale. So sometimes you might be like, well, that's definitely a 90-degree angle, but it's not always. One angle might look slightly bigger, but you have to pay attention to the numbers that are there, not just what the diagram looks like. Okay, so I'm trying to find the largest angle and the smallest angle. So we have largest and smallest. Alright, so I'm going to first find my largest side, which is 40.31, and go across, which is angle K. And then my smallest, I'll go ahead and find my smallest number and go across, so angle L is my smallest. Alright, go ahead and try that again with number 4. I'll give you a couple seconds to try it. Pause the video if you need to. Alright, and here is number 4 with the largest angle and the smallest angle. Alright, let's go ahead and take a look at number 5. So list the sides of the right triangle in order from least to greatest. So I'm going to go ahead and draw my arrows, and I'm going to kind of number these from 1 to 3, from largest to smallest. Alright, so 110 is my largest angle, so therefore AC is my longest side. And then I have 38 would be next, so BC. And then 32 is my smallest angle, so now I have BA. So I've now listed all of my sides from largest to smallest. Another way we can do this would be BA, BC, and AC. Oh, and I guess it did say least to greatest. I definitely went largest to smallest. I apologize about that. So that would just be the other way around, from smallest to largest. But another way you can write this is with inequalities, because what this is saying is side BA is smaller than BC, which is smaller than AC. So therefore, using this inequality is really good to show, oh, see, this is the order of the lengths. BC is that middle length there. AC is the largest. BA is the smallest. All right, and then we could do the exact same thing with angles. So number 6, we want to list the angles of the triangle shown to the left in order from least to greatest. So I'll make sure to do that better this time. Smallest to largest instead of largest to smallest. So let's start with 5. So I'm going to go across. That would be X. And I'm going to use the inequality way again. So X is less than, now we have 6, which is less than Y, which is less than, we have 7, which is W. I'll also list it this way so we can see it. So X is smaller than Y, which is smaller than W. So Y is the largest and X is the smallest. All right, and now 7, triangle ABC and is show to the right. Which statement below is true? So I first want to figure out what this third angle is. So remember, if the triangle sum theorem, all the angles need to add up to 180 degrees. So therefore, if I take 180 and then subtract 48 and subtract 39, I'll end up with 93. Okay, so now I can look at the sides and the angles appropriately when reading all my options. So BC is the largest side in the triangle. So BC would be here, which is across from 48. 93 is my largest angle, so therefore A cannot be my answer. Okay, AC is the smallest side, so AC, smallest, which means it should be across from the smallest angle. 39 is my smallest angle, right? 39 here. Oops. 39 is my smallest angle, which means AB is actually the smallest, so it can't be B either. Okay, and then AC is the largest side. Let me go ahead and highlight that up again. AC largest, 93 is my largest number. All right, that one does check out. And then D, just to check it, it is not possible to find out which side is the largest in the triangle. Well, we just did a bunch of examples of being able to do that, so therefore we are able to find some sort of answer to this. All right. Okay, let's talk about inequality symbols. Just a reminder of them. So this symbol here is the less than symbol. So if I had 2 is less than 5, right? All right, and then this symbol over here is greater than. So if I wanted to, I can switch that around, so 5 is greater than 2. Okay. So using what we remember about our less than and greater than symbols, let's figure out which statements are true, and we need to select all that apply. So it says P is less than Q. So we have P here and Q here. So if we think about their opposite sides, let's point the other way. So we have an 11 and a 9. So Q is greater than 11. And this says P is less than Q. So 9 is definitely less than 11. You can plug in those numbers there. That one checks out. All right. Q and R. So let's continue to do it that way. So we have Q and R. So we have 11 and 7. So Q comes first. So we have 7 is less than 11. That one is, oh, I just realized I wrote that one backwards. Q comes first, so 11 is less than 7. That is not true, so B is not one of your answers. All right, but see, it does flip around those numbers. We're still using R and Q, but switching them around, so 7 is less than 11. That one is true, so therefore C is the answer. So you need to be very careful when you see letters like that. That's actually something I just did. I just started to look at C instead of B, and I was like, oh, R and Q. 7 is less than 11. But then I realized, oh, it's Q is less than R, so I had to make sure I put those numbers in accordingly. And 11 is not less than 7, but 7 is less than 11. All right, now I have all of the letters. I'm just going to plug them into the inequality to decide if it's true or not. So let's go ahead. R will be 7. So 7 is less than, which is P, which is 9, which is less than Q, which is 11. And that does check out. 7 is less than 9, 9 is less than 11, and if you read it the other way around, 11 is greater than 9, and 9 is greater than 7. So D works as well. All right, let's go ahead and take a look at our second exploration. All right, so let's go ahead and I'll go ahead and open that up. There it is. All right, so what we need to do, we need to figure out, can any combination of side lengths form a triangle? Find a combination of side lengths that cannot form a triangle, write down the side lengths, and then make a conjecture. All right, so I'm going to go ahead and mess around with this a little bit. Hopefully you have it out on your own page. I'm going to go ahead and use these coordinates that it gave me already. if I can get them. Alright. Let's see, let's make these smaller there. Alright, so this would be a really good example for the second bullet point on side lengths that do not create a triangle. The 8 and 3 do not touch, so therefore this cannot create a triangle at all. And then this would also answer your first question. Can any combination of side lengths form a triangle? No, they cannot, because we have 8, 3, and 18. Alright, then we want to make a conjecture. So go ahead, think about a conjecture. I'm going to mess around with this just a little bit more. Alright, so the conjecture for this one that I came up with is that goes along with the triangle inequality theorem, which is you can't have two sides have to be greater than the third side. So whatever that third side is, the other two sides, when you add them together, have to be greater. So if we, I'm actually going to go back, what were the side lengths? I think it's like 8 and 3, right? So 8 and 3, if I add 8 and 3 together, that's 11, which is not greater than 18. But I think I had like, what is it? Let's do 11. So 8 and 11. No, I did 12. That's right. 14 is fine. So 8 and 14, if I add those together, that's definitely greater than my 18 there. So therefore, it creates a triangle. Okay? So for any real triangle, the sum of any two side lengths must be larger than the third side length. So let's do 3, 4, and 5. So if I do 3 plus 4, it has to be greater than 5. So 7 is greater than 5, so that one checks out. Let's change up the colors. Let's do 3 plus 5. Has to be greater than 4, so we have to be using all the side length. It's not going to be greater than 5 every single side, every single time. So now I have 8 is greater than 4. That one checks out. And then let's do one more, which would be 5 plus 4 has to be greater than 3. So 9 is greater than 3, so that one also does check out. So therefore, this triangle is true. So when we are trying these examples here, we just need to add all the side lengths together. If we come across any that is not greater than the one that's left out, then it's not true. So let's go ahead and try 9. So we have 3, 10, and 5. So I'm going to add 3 plus 10, which is 13. It is greater than 5. That was my last one left out, so that one works. All right, and then let's do 3 plus 5. 3 plus 5 is 8, which is not greater than 10. So therefore, 9 is not a triangle. Okay, let's go ahead and try 10. So I have 7 plus 7 is 14. That is greater than 13, so that checks out. And then I have 7 plus 13, which is 20, which is greater than my other 7. And of course, we'd end up doing 7 plus 13 again because we have two 7s. So this one checks out. So number 10, this would create a triangle. And if you need to, too, while we're working through these, go back to the exploration and plug in these values and see if they do actually make a triangle or not. All right, and let's take a look at 11. So we have 5 plus 5 equals 10. So looking at that, you might be like, oh, great, it's greater than 10, or it's equal to 10. But it has to be greater than. So it can't just be the same length as, it has to be greater than. So therefore, this one is not a triangle. All right. All right. I want you guys to go ahead and try 12, what is that? 12, 13, and 14. I don't know why I repeat 12 2 times, but these next three ones, I already have the answers written there, so I want you to go ahead and give them a shot. If you need to, go ahead and pause the video. All right, and here's the answers for 12, 13, and the second 12. So 12 is yes. I didn't put down all the options, but it was yes. 13, 4 plus 4 isn't greater than 8, so it's not a triangle. And then 12, 3 plus 12 is not greater than 18. Okay. All right, and then our second 13, create side lengths for a triangle that would not connect to form a real triangle. Explain your reasoning for choosing these side lengths. So I'll give you a second. You go ahead and come up with one on your own, and then I'll show you one that I have come up with. All right, and I just did 1, 1, and 2. So this couldn't be a triangle because 1 plus 1 equals 2 is not greater than. Okay. And our last part of our notes today is the different range values you can if you have a missing side. So if we look at 15, 16, and 17, we have 2 side lengths, and we have to figure out what the third side length could possibly be. So there is a range of values that it could be. So we can do a minus b is less than x, so x will be our missing value, which is less than a plus b. So if we take the two values, we subtract them, be on the left, and then add them, be on the right. So if we start with 15, I have 5 and 12, so I'm going to do 12 minus 5 is less than x, which is less than 12 plus 5. So we end up with 7 is less than x, which is less than 17. Okay, then we try that with 8. So we have 8 minus 8 is less than x, which is less than 8 plus 8. So my answers could be 0, anywhere from 0 to 16. So remember, it doesn't include those two values. It's just between those two values. So essentially, I can have values from 1 to 15. All right. And then let's try one more together before you try a few on your own. We have 10 and 3. So I have 10 minus 3. And then we have 10 plus 3. So I have 7. X is less than 13. So my x value can be anywhere between 7 and 13, not including 7 and 13. So therefore, it could be 6, 7, 8, 9, 10, 11, or 12. All right, go ahead and try 18 through 20. I have the answers written down already, so they're at the very bottom if you're reading my page or my screen. Go ahead and pause the video if you need to try these out. All right, and here are the answers for 18 through 20. Let me know. Well, that's it. Not me know. Let your teacher know if you have any questions, because that is the end of 5.1. So make sure rewatch the video as much as needed, ask your teacher for questions, and have a wonderful rest of your day.